At the top of page 2 for the notes for 10.3, we're just going to run through several examples of utilizing the quadratic formula. And you'll notice I've sprinkled in here the question, what's different? Just so wise to pause and take a peek at how things are progressing and how it might affect our results, because the steps are going to stay the same. Get it into standard form, which means you move every term to one side so that the equation equals 0. You identify your a value in front of the x squared, your b value in front of the linear term, the x piece, and the c, the constant, and plug those values into the quadratic formula, which once again is negative b plus or minus big square root b squared minus 4ac is in the square root, the whole thing over 2a. And this is your value for x when your quadratic equation is equal to 0. So let's look at a few of these. Again, the steps are always going to stay the same. The reason why we're going to start asking what's different is because you'll notice that it affects maybe what you plug in and also the look of the final answer here. So let's start with number 14. X squared plus 6x minus 10 equals 0. Our a value is 1. It's the number in front of the x squared, the coefficient. Our b value is 6. Both of these happen to be positive. And our c value is negative 10. Keep those signs. And then just to help ourselves memorize the formula, we're going to write it out every time. So negative b plus or minus big square root b squared minus 4ac, the whole thing over 2a. And I'm going to go ahead and write it again, only this time leaving some workspace for all those values. Negative b plus or minus big square root b squared minus 4 times a times c, the whole thing over 2a. And then I put my pieces in. In this case, b is positive 6. There's another positive 6. A and c, a is 1, c is negative 10, and a on the bottom is 1. And you'll get into a rhythm plugging it in as well. Try not to be random. If you can do it the same way every time, it's just like the pro basketball players shooting their free throws. They come up with a routine, they do it the same every time. Watch them, and the high percentage free throw shooters have a way they do it. They keep it the same. They found their rhythm. So you might decide that you put the A's in place, then the B's, then the C's, alphabetical. You might decide you just go left to right, do all the tops and then the bottoms. However you do it, just do it the same every time. You'll find your brain can memorize these things. Our brains are powerful. Just give them a chance. Then we're going to simplify here, so we get negative 6 plus or minus inside the square root. 6 squared is 36. Minus 4 times 1 times negative 10 is positive 40. The whole thing over 2. And then that becomes negative 6 plus or minus the square root of 76 over 2. This does simplify. The square root of 76 does split into radical 4 and 19. So you get negative 6 plus or minus radical 4 times radical 19, using our chapter 9 skills here, being able to simplify radicals, whole thing over 2. Don't be too quick to cancel. Remember, we've got adding and subtracting happening, then we're not in total multiplication yet. From there, and I think I'll just scoot on up here to give myself a little bit of workspace. From there, I've still got negative 6 plus or minus radical 4, radical 19 over 2, so I just copied it so I wouldn't make a mistake here. And then I'll move on with the math. I do know radical 4 to equal 2, so this becomes negative 6 plus or minus 2 radical 19 over 2. And now if you look at every term, the negative 6 is a term, the 2 radical 19 is a term, and the 2 underneath, they all have a 2 in common. So if you recognize that, now you can do some undistribution, some factoring. So I'm going to pull a negative 2 out of the top. Why negative? Well, my lead number there is negative, and that gives me the clue that I would like to pull that out. So I'm going to pull out a negative 2 from the top, or undistribute, factor out the GCF of negative 2. All of those terminologies, whatever is comfortable for you and makes the most sense. So that leaves behind a positive 3. The plus or minus, don't worry about that, because if you pull a negative from a plus, it becomes a minus. Pull a negative from a negative, it becomes a plus. So you still have a plus or minus there. the 2 radical 19, when you undistribute that 2, you're just left with the radical 19 and the whole thing over 2. And now the 2's can cancel, and you're left with the negative 3. Negative on the outside, 3 plus or minus radical 19. And really this negative, once you distribute it back in, I guess I didn't really need to pull a negative. I'll have to remember that next time, that it really doesn't affect unless I had a negative on the bottom. So that was a little premature of me to insist that we pull that out there. But we'll just redistribute it back in so we don't have to chisel any more parentheses there. So negative 3 plus or minus radical 19. And notice the plus and minus indicates that we do have the 2 solutions. So it's not a pretty number. Radical 19 is irrational. It's a decimal that does not repeat or end. But this does give you 2 real numbers that are solutions for x for this quadratic. And as we move into 10.5, we'll talk about what the significance of those 2 solutions are. Let's look at 18. What's different about this one? Compare this one to what we did before. Some of you might notice that it was a positive value of b, negative value of c. This time we have a negative value of b, positive value of c. Sure. Does that change how we're going to do things? Nope. Then some of you might notice, hey, we have an a value this time. Instead of just a being 1, it's an a value of 3. Again, does it change anything? No. We're still going to pull these coefficients, keep the signs with them. If there's a negative, we're going to use that negative in the formula, and we're going to plug them into the formula. So there it is, negative b plus or minus whole thing, big square root b squared minus 4ac, the whole thing over 2a. So here's my formula again, negative b plus or minus big square root b squared minus 4 times a times c, the whole thing over 2a. And we've got our b value of negative 5 and another b value of negative 5 that's going to be squared. Our a value and c value underneath the radical here, our a is 3, our c value is 1, and then our a value on the bottom is 3 as well. And when you start to simplify that, you've got a positive 5, negative times a negative. It's going to be a positive 5 plus or minus. Inside the radical, we've got negative 5 squared, which is positive 25. Minus 4 times 3 times 1, which is minus 12. So we've got 25 minus 12. That's going to be radical 13, the whole thing over 6. So this one actually works pretty nicely here. 5 plus or minus radical 13 over 6. Pretty straightforward. Nothing can simplify there any further. So take a moment and talk somebody through what you've seen. Note any questions you might have. Make sure it makes sense for you, and then try number 4. Pause the video and come back to see how you did. After you apply the quadratic formula, a value of 1, b value of positive 5, c value of positive 2, your answers for x should be negative 5 plus or minus radical 17, the whole thing over 2. And I'm happy to do these try ones, anything from the notes really during class. That's what class time is for. Make sure you bring those questions.